the problem of Goodharting. You might be knowing about that, proxy gaming.
Mhm.
So that is already a problem with respect to intelligence. But given that my field and my interest is with respect to ethics and wisdom, so proxy gaming, when it comes to wisdom, then it becomes even more problem. I've written a statement about this, that intelligence can simulate wisdom, but wisdom is not simulating intelligence. I'm trying to understand how could interpretability help with respect to solving good hearting or solving the proxy gaming problem with respect to wisdom. Because when we talked last time, you told me basically, like, told me, convinced me, explained to me how interpretability is a good enough problem to work upon. Because earlier I generally used to think that it is nearly useless because it will be very short term. After a point, even if we can interpret machines, it will become useless for us. But now, like, I think you're on that track only to make converge interpretability with scalable things.
If I'm thinking about a system having like a target, like maybe a regulation target or like a goal, that I have like specified, then okay, like if it's why the thing is the goal is like, okay, why do we have a proxy as a concept in here when we have a clearly specified goal? The thing is, often you cannot actually follow the actual goal. You have to follow a proxy. And one reason why that is the case is because the agent doesn't understand the goal well enough to sort of follow it. Like the sort of true goal is not accessible to the agent. It has some representation that it can follow, that it can measure against, and so on. It has sort of limited access to what's going on. And so it sort of follows that thing. And I think with high interpretability, what you can basically do is, so usually if a system follows a goal, when you first put in this goal and sort of test it and so on, and you say, yeah, this is good, like maybe it is a good proxy. Why does the situation change? Like, why does proxy gaming become a problem? Well, sort of the situation changes. Like maybe the agent gets a better understanding of the environment, or like it. So that could be due to different reasons. So basically, one way of imagining is there's like a big causal network of how you can navigate the possible states of the environment. And so you have a target state, you have a goal state, and now there's sort of two classical things that can happen. One thing is I upgrade the resolution of the whole thing, and now my goal state was at a sort of low resolution thing. Now that I'm looking at a higher resolution, I can actually match many high resolution pictures to the same low resolution picture. And so now the agent just changes whichever one of those is the most convenient. And that's a problem because we want the selection of the higher resolution picture that fits with the lower resolution one. We want that to be more selective. Like we have selection criteria as well for how to do this selection task. This is sort of the one classical thing. The other classical thing is, okay, you're still trying to solve the same thing, like you're still looking at the same picture, but now there are more different pathways available to you to sort of reach the same outcome. And again, we don't specify automatically, at least, or like per default, we don't, which of these possible pathways are okay to follow. So there's an issue if the agent discovers new pathways or a new level of resolution. You need a sort of judicious way of saying, okay, whenever you're basically the granularity of the state space that you're sort of navigating, there are different ways of updating from like basically a model of the state space that the agent can do. And whenever it does one of these updates, you can say, okay, now we need to apply a process that says, okay, which of these available pathways are okay? Or like, how do I evaluate which of these are okay? Which of these like more precise pictures, more precise like versions of the target state should you actually target? And interpretability allows you to sort of look into how the agent models the target state at a higher level of resolution. And this is sort of the prerequisite for you to say, okay, which of these new options do I want to aim at? Can I sort of employ some general algorithm or some learning principle that tells the agent which of the sort of new options, like given that it has a better understanding of the world now, which is sort of one of these things usually, how is it supposed to navigate the world with its better understanding? How do you make that update? And sort of the interpretability is a bit of a sort of prerequisite that you can have for saying what in general the higher level resolution perception of the agent will look like and how to make that update.
Okay, so basically again the fundamental point of interpretability is to see what is actually going on inside the black box, but we can see why a proxy is being selected as proxy by the agent and not the main goal, and why among all the paths available the agent is selecting one specific path to reach that goal, right? So it's like already the main goal that we're going is kind of terminal goal, so the instrumental goal that is selected by agents, why is it selecting the specific instrumental goal, right? This is how we can actually see it, because we know that it is selecting some other instrumental goal or some other proxy, but we can see that it is which specific one it is selecting to, which what is the specific proxy. But the point here that I get confused all the time is what benefit it will give us, like even if we know that this is the proxy that that the agent is selecting. So and then we try to understand from our intelligence, like human intelligence, we then
Mm-hmm.
that the agent is choosing this proxy because this is the reason, that then the reason that we are figuring out is we are figuring out as us, not as the agent, because we can never know why the agent chose that proxy specifically. So how can we know what the agent thought basically in a way to choose that proxy? We can know which proxy does it choose, but why does it choose it? How do we know that? Then we'll have to do the interpretability of interpretability, like that kind of thing. We'll have to go.
So you can probably generate an actual explanation why the agent is choosing it. So at least insofar as anything counts as an explanation. Like you can, like if I have the agent and if I now say, okay, the agent will, like after 10, I don't know, after 1,000 time steps, the agent will have a higher level perception, like a higher resolution perception of what's going on. So rather than seeing one goal state, the agent sees like 100 possible goal states that all qualify as the correct target, like from the perspective of the evaluator that the agent is sort of working with. And so can I predict which of the 100 possible states that are all valid the agent chooses? And like one default prediction would be, oh, it probably chooses the one that is easiest to accomplish from the 100 possible ones at this sort of higher level of resolution. And that's a good thing to know about the agent. Then I can say, oh, I can predict it will go the path of least resistance, or it will go, it has some metric according to which it determines what is easiest.
Most
And
efficient path. Basically, we are not actually understanding why the agent is doing that, but we are predicting it, right? And to predict
if I can perfectly predict what the agent is doing, that is sort of similar.
It seems like some loop that will keep on going in this way. Like, uh, okay, first we had a model, then we did the interpretability thing to see that which agent is like it will become again an input and output, and then we will again make up again model to predict the input and output. Basically, we first had an input and output, and then we interpreted it to see that which inputs are matched to which output, and then okay, let me try to rephrase it. Okay, so yeah, on the broader level there was a user that gave set of inputs and gave outputs, and then tried to find a pattern, like that kind of thing. Then we see that agent is choosing this kind of proxy for this kind of input, right? And then we again, the proxy has become the output now, and then we again use a model to predict which inputs will give which kind of proxy, that which proxy will be chosen by which agent, or which agent or among the 100 proxies, which proxy will be chosen by the agent. Then we are trying to predict this. Then we will have to understand that why is that specific this model that we have made, why is it making the agent choose that proxy only. So my point being, it will be again a recursive thing. We can keep on doing this, and we, since we are not actually finding a why, we are just finding set of data points like this. Am I clear now? I guess.
I think I'm not either you're not clear or I disagree. Like I think I should be able to, like, let's say I do this with a very simple agent, okay? Like I'm looking at an idealized setup, and I'm just, we're not talking about a complicated agent here. We're talking about basically an algorithm that I can understand. This algorithm is doing some modeling of its environment, and I just give it a better ability to model the environment now. Like I just give it the ability to model this at a higher resolution. And it should be just sort of deterministically predictable to me which of the sort of new goals that the agent sort of could now pursue out of, like, let's say it was 1 before and now it's 10 or something like that. I can just look at the algorithm and sort of understand, oh yeah, like it's choosing this one because there's this other part of its like utility function, of its evaluation function, that obviously favors this one rather than the other 9 in the new landscape of evaluation. So I know that for this agent, if I increase the level of resolution at which it perceives the world, it will always favor the new state that scores best on this particular metric, because this is sort of what's part of its evaluation function. So I can say, okay, this evaluation function works well for the original level of resolution, but it's not, we haven't put in enough thought for like this internal part of the structure of the agent for this one. And I can actually sort of generate arbitrarily deep with this knowledge. I can say no matter how often I increase the level of resolution at which the agent functions, I only need to know this one fact about this new level of resolution to predict what specific behavior or like what specific outcome the agent will target. Like that's a good benefit of interpretability here. Where if I can sort of have this level of mechanistic understanding of the agent and saying, oh yeah, this circuit here, this part of the evaluation function tends to favor this, this particular value or this particular aspect of any possible candidate for like a target, basically.
Okay.
And I don't see the recursive aspect of that. Like I just have a basically causal model of my agent.
Yeah, I get
and
it.
this
But
causal model. Yeah.
so basically, through interpretability, what again the way that you explained is we are now predicting the exact proxy that the agent will choose among all set of proxies, right?
Mhm.
Given the resolution thing that you're talking about. So my point being that to predict this thing, we must be using some logic, right? And that logic is found by us humans, right? So
Mhm.
the intelligence that we are using, or the way the way that we are thinking, we are assuming that that is the same reasoning that the agent is also using,
Mhm.
because there is no specific way to know that if the agent is also using the same reasoning that we are using.
Well, you can construct it, right? You can say, okay, like there's certain pathways of reasoning that are like these are like the atoms of reasoning for the agent, and anything else is a composition out of these atoms, right? Uh, like there's some reasoning operations, if you want to call it that, or like modeling operations. Like how does it stick together a world model, and like how does it do reasoning on an existing world model?
Mhm.
And if you can understand like these two processes, like both the sort of word model or scene construction and the sort of determination of the action given a certain scene, like how the agent does this, this doesn't need to be uninterpretable. Like you can just say, okay, it does this particular computational process to sort of figure that out. Or like there's this sort of learning or feedback loop to select which of these possible atomic operations it should use, but the sort of ground level of operations, they don't need to be changed. Like the learning can just happen on top of that. And like the basic operations will always remain
Mhm.
interpretable.
This is similar to what we talked last time about abstraction, how abstraction can work as a great plugin for increasing the amount of intelligence. And now you're
Mhm.
basically putting abstraction, basically by interpreting we are getting an abstracted understanding of the model, the how does it work in that kind of way. So now you're putting abstraction as a feature or as an element for explainability in that kind of sense. So yeah, on abstracted level the logic works in the same way, be it human logic, be it machine logic, that can be said, the what you're calling as atoms of logic, that thing. So the more abstracted level we go, the more equivalent it will become. The lesser the proxy difference will be there, the more abstracted we go. And through interpretability mechanism we can go a different deeper level of interpretive abstraction. But the recursive thing that I was saying is, again, we are at this moment the first level of abstraction, that is when we interpret the model the first time. Okay, so okay, wait, let me just clarify things. How are you predicting what the agent will, which proxy the agent will choose? To predict this, what you are doing? Like we are using again a different model, right? Or we are how we are predicting this?
Like it's a computational system, and like we can say, like we can have some knowledge, some rules about like what kinds of operations work in such a system. Um, a certain sort of computational universality and so on. It's not like you can actually say, oh, it's using machine logic and this is different from human logic, and we can only, to some limited degree, understand machine logic from human logic. It's the same system, right? Like overall, these things are deeply translatable.
Yeah, yeah. With this aspect, but when we try to give machine a goal, then it makes a proxy of that goal, because the machine logic that it forms of that goal involves the proxy, not the actual thing. Like this level I'm talking about. The machine logic is the logic might not be different, but the way to interpret the logic will be different. And the more we go towards the, if you have gone to the points of discussion in that I wrote, the more abstracted level we go of a thing, the lesser chances of differences exist on that level. The atom thing that you're talking about, at atomic level all things are same, but when they are when they are implemented, then it becomes different. The logic that way humans use is different, and the logic that the machine uses is different. That is why when we give our logic to machines directly, then there is this proxy gaming problem that exists. Basically the Goodharting thing exists. So to solve this, again, this is a good way to go toward the abstracted level and give the logic, that we the human logic to machine logic, in the abstracted form, so that it can come to machine also in machine form. But since we are giving it in the abstracted form, then it is better aligned. So basically it's like it is easier and better to align our goals at an abstracted level than to the implemented level. Is this being clear how it is happening?
I see what you're saying. It feels like you're sort of saying, okay, there's this, I don't know, like there's sort of this sort
Yeah,
of pyramid thing, and like
not
over
a
here we
pyramid,
have sort of have
like a U shape kind of thing.
yeah,
At base we have a logic, similar kind of logic. When humans see this, then they make a human logic and human goals and everything like that. But when machines see it, they will make different set of goals and different set of logic, but they will use the same logic at the level, at the base level.
yeah.
So if we give something of our logic of our terminal goal to machines, then they will interpret it as different thing, and then they will have proxy gaming thing, because we are transferring on the implementation level. But if we abstract our logic and we give them to the base level, at the base of the U thing, where the logic remains same for everyone, the atomic thing of logic, and then we give to the machines, then they will not have to use proxy for that. It's like that.
Yeah, I still sort of see that image. I do think there's a confusion here about like levels of abstraction, though. Like like usually when we're talking about high levels of abstractions, it's like high level of abstraction usually means lower resolution, right? Like I have like basically like a conceptual category for multiple things, and I say, hey, like I'm abstracting away from a particular thing to the concept of sacrifice or whatever. Sacrifice just means giving something up for some other benefit. And like this is a more abstract thing. Like I can like these are like placeholders I can put in various things in here. So that's an abstract concept. And atomic things are sort of in some sense the opposite of like really abstract things. Although I can say that the atomic things, like the way that I selected the atomic things to begin with, were according to some more abstract insights about logic. Like I can say, okay, I have like abstractly constructed a logic system, and I can now prove in this logic system that like this number of operations, like this set of operations is sufficient to construct across each other all possible operations that are even expressible in any language that is consistent. And so I can now sort of use the set of operations at the bottom, like as an atomic layer and so on. So there's a sort of relationship there. But usually, if we're talking about atomic things, we're sort of, in some sense, talking about the opposite of abstraction. But you can have like a feedback effect like this. So when we're talking about the sort of U shape and what's at the bottom there, we're sort of talking about the atomic thing, I presume, because it's like the basic logic operations or like basic sort of addition, subtraction, and so on, like the inarguable sort of mathematical realities where we can just sort of easily compare and say, okay, like this is most assuredly the same thing. But when I sort of go a little bit up here and say, okay, I have this concept of what is a person, how do I ensure that my concept of what a person is, if I go to the other side of the U, also the same concept that the machine is? And the thing is sort of two things. Like one thing is, okay, the sort of where this U arm for the machine is, that is like a variable thing, right? This is not sort of set in stone. We have some power over that, probably insufficient power. We can't actually sort of make this thing sort of right next to us, or we would like to, but it's difficult. Like, or at least we don't know how yet, and we don't know at all like how to direct the sort of second arm of the U really. And this is in some sense the goal, right? Like we would want them to be close enough together so that we can actually build stable bridges across this.
That is the goal.
And we can say, okay, like these bridges are actually solid. Like I can actually go over here. I don't know what happens, in all of this, but actually, like by seeing that these bridges hold, I can have like some assurance of translatability, even if I can't like live over there. I know that there's a like, okay. And the thing is just, I don't know, you just build the tower like step by step in some sense. Like the reason why I'm talking about a very simplified system where I should actually be able to sort of do the whole interpretability thing end to end and sort of predict, perfectly its behavior, because I can actually like fit the entirety of my system into a sort of predictive model or whatever. Like I can actually just have a pretty simple theory because the system itself is pretty simple and say, okay, like if the resolution is higher, then it will always choose this thing. And even if the resolution gets even higher, it will also choose this thing, because like the way my agent looks like, it's sufficiently simple. It's just sort of, it's like proving like some mathematical series, right? Like some number series. I can say like, for whatever n I put into this equation, I can show you what the result is going to be. Similar thing here. The difficulty is just if the sort of AI agent that I have becomes basically intractable to interpret. It's just too complex for this to be like a valid strategy to interpret everything. So I need to be able to say, okay, I can't tell you exactly what its concept of a person is, but I can tell you that like the sort of things that we put in place in order to sort of choose and sort of determine and maybe refine, like make updates to its concept of a person. I can say, oh, like the actual concept of a person, I don't know, but like the update mechanism for like how to make the concept of a person better, maybe this portion of the software I can explain. What I'm trying to say is, okay, like just don't build the thing unless you have like all this extra structure. Like you basically build this little part of the U, and then you build a bridge over, and you sort of check, okay, like is this stable, does this fit? And only then, like only under certain conditions of assuredly, even if you can't interpret everything of it, if you can like have this sort of stronger bridge thing, then okay, maybe you're now allowed to build the next floor, basically.
So basically, interpretability is about building bridges. The recursion thing that I was talking about is about building the bridges at different levels of abstraction. Again, you did not like clarify me this. How are we predicting that which proxies will be chosen by the agent? Are we using some some model? Are we using another model to predict the proxy, or are we using some other method to predict which proxy will be used by the agent amongst the proxies?
That sort of depends on how complicated the agent is, right? So if the agent is if I'm looking at a really, really simple system,
Then we can obviously predict
in some sense, it's like but it's still remains a bit of a fundamental question, right? Like if the system is predictable to me because it fits into my own head, then I sort of sidestep the problem a little bit. It's if it's predictable of like all the mechanics, if it's like if it's a fully deterministic system in a sort of obvious way, that it can predict it. Another predictability aspect is, of course, if like about computational reducibility, right? Like maybe I don't need to actually run the system; it sort of predicts what its reasoning process will be to sort of arrive at the conclusion. Maybe I can take a shortcut and say, okay, rather than having this sort of sum of things where I sort of actually need to go through every step, I can just sort of do, I don't know, I can sort of multiply whatever, right? Instead of adding everything.
So the way to predict the proxy that an agent will choose out of given proxies depends upon the complexity of the proxies, right?
Yeah, so you need to have this. So the thing that's often missing if you're sort of just looking at it is like, okay, obviously the environment itself will like supply possible proxies, because it's sort of the environment in some sense in interaction with the agent supplies the next level of resolution, and among those you have like distinguishable possible proxies, and then if you have that already clear, then it's sort of easy to say, okay, given what I know about the agent, I can now say which proxy it will choose. But what I haven't accounted for is the interaction between agent and environment, so that these available proxies sort of pop out with their different features that are like both dependent on the actual features of the environment and of the perception that the agent has. Like maybe the agent has a very like limited perception of the environment, and that really informs how it thinks of different proxies as its sort of resolution gets upgraded of its limited perception. Like maybe an agent doesn't have any eyes and can only hear, and gets better and better at hearing, but that's still like that really informs the sort of proxies that the agent will encounter.
Yeah. No, I'm not talking about the, well, that is a thing to say based on perception, but I'm talking about the matching of the environment and the proxy. How will that happen? Are we using another model, or we are just using plain mathematical equations, or are we using some Bayesian technique? Because in, as I said, in simpler cases, when it, like after one level of abstraction, if it becomes easier for us to like you do like without any modeling thing, then we can do it using mathematical thing. But if the initial problem is complex enough that we
Mhm.
need, when we interpret it, then also it will become easier, but it will still be complex enough to like just predict simply. Then we will again need a model to again predict that kind of proxy and environment pairing. And then for that again, if after that level of abstraction, if it becomes easier for us, we can directly do some mathematical equation. But if it is still not easy for us to compute like the scalable thing, then we'll again need a model for that to match that
Yeah,
level
but
of
as you're saying,
proxy.
like, expectedly, it sort of gets simpler and it sort
Simpler,
of
yeah,
bottoms out
yeah.
at the level of
So
mathematical equation.
so the complexity of the upper task or the main goal uh, defines the amount of complexity of the proxy, that defines the complexity of the second proxy, third proxy, like that, the recursion thing that I'm talking
Yeah.
about. So given like if we are not talking about the simpler cases or toy cases, that for example, if we're talking some real world problems and all that chaos, then the main goal and the proxy are like in huge amount, like beyond human comprehension in some cases.
Hmm.
So in that cases, at least we'll need 3 4 level of abstraction, and we'll need
Sure.
3 4 level of interpretability as well. Like we'll need to build 3 4 bridges at different level to connect the u properly.
Yeah. Yeah.
And
Absolutely.
the recursion will keep on happening. And this was my, like this was my point, is again, is first of all, it is computationally too heavy to do it. It like building different level of bridges, it is too expensive with respect to resources and all. The other problem with this is, if the upper problem
Mm.
that we have, it grows exponentially, like the problem with value and ethics lock-in, that different set of ethics have different set of alignment that machines cannot understand. So for each set of you, we will need each set of bridge. Like for, let's say, Indian value, Indian ethical system and the machine ethical system, for that we need 4 level of abstractions and proxy simulations, whatever proxy models.
Mm.
Like for other countries, we will need another. Like my point being, it is just too much to do, basically,
I think there's
for
gigantic overlap
complex
between
problem.
different countries and cultures. Uh, so that like the main pillar of the sort of one arm of the U basically is going to be pretty universal, and then you only have like
Yeah,
slight divergences
yeah.
that are probably, I don't know how difficult they will be, but that seems feasible. Like it's not one U per country or
Yeah,
something
it's
like
not
that, I
like,
would
it's
say.
like one off machines and then all other are around. I'm not talking about a country, but uh, there can be other set of like ethics and morals are just one aspect of human society in life. But there are other proxy gaming, other problems that can happen, like some normal things, some normal other things that that machines can misinterpret. So for each thing again, it's like there's one major thing, then it's like one set of people divided by country or culture. They have their own set of ethics, their own set of morals and all these things. And their and sciences, like my point being, there will be a lot of bridges to build, because there's a lot of there's too much diversity among humans in itself. So since there's diversity in humans, but machine thing, that's good that machine you hand is single, but humans hands are not single. I don't know how to describe it. They all are very different. Humans and their culture and society is different. So if like some of the things of humans are similar, mathematics of all humanity is similar across the globe, but culture of all humanity is not similar. At different places, the culture is different. So with respect to math, we just have one bridge to build, one set to align. But with respect to
Mhm.
culture, we have a lot of bridges to align. And there again, politics is different. Um, a lot of things are different as well. So that way, we will have
Yeah.
to, for things like mathematics, we can do it once and we can generalize it among all humans. If we do interpretability and at abstraction level, we align things and then we propagate it above. But with other things, we will need to build like all, and like recursively we will have to build for each set of groups of people. And the other problem that we will get here is the problem of value locking, that at this moment we have this problem of with respect to human having some specific kind of value system, but after a point the value system will change, and so we need to, like, the you stand will change, the human's value will change, and that will become a different problem. Obviously this is not specific to your own field. I have diverged toward my field of ethics and
Yeah.
wisdom and all, but I'm like, from seeing it from the ethics point of view or wisdom point of view, it becomes a problem. But from your point of view, like, I think you just have to align maths and science, that thing only. The rest things have to
No,
be
no,
done.
no.
My part is done now. You see yours.
No, no. Look. I really genuinely don't think that the sort of human diversity is that big of a challenge. If you have a system that you can, like, I feel like if I can align it to just one culture, then it's almost trivial to align it to all cultures simultaneously.
Yeah, because at abstracted level the cultures are same as well. Yeah, that yeah, because humans are same. But
Like,
humans themselves are
we
not.
might look very different to each other, but sort of for an intellect that can actually have like a stronger, like, one reason why phenomena look very different is because we can't like grasp the generator function that's sort of pretty simple, that leads to all like this branching out complexity. That we could actually like summarize very elegantly if we sort of understood how to talk about the laws of nature correctly and so on. Like, there are many things mysterious to us because we don't like we can't sort of simulate them in an elegant way in terms of like how they come to be this way. I think an AI will probably be capable of doing this. Like, the sort of U arm of the AI is going to go a lot higher or going to be a lot thicker or more powerful than our sort of human thing. Expectedly, like if the AGI concept sort of works out at the end of the day. And like the thing, I mean, humans are pretty diverse, but I think, yeah, I think that part doesn't seem to be like getting it to be ethical in the first place in a way that actually sort of generalizes automatically, even as it upgrades level of resolution. Like, if the AI figures out a new scientific invention or like figures out some new laws of physics or whatever, and you, and sort of still knows how to apply this novel thing in the correct way. Like, we would have to sort of generate ourselves, right? We would have to think about, this is new, like maybe anti-aging. Like, here we go again. Like, it's a really complicated thing for us humans to figure out. Different cultures, how the relationships should be, the geopolitical thing, like how will this develop in the long term and so on. It's actually difficult for us to figure out. Like, we're not just sort of automatically aligned on this. And if like the AI can do something like this with respect to just one human group, like, or just sort of humans in some very general sense, like figure out how to sort of, from the possible options that a new technology gives, like select, like have good judgment on which ones are like okay, then I'm thinking, yeah, okay, the rest is pretty simple. Like, just give me an AI that does this.
Exactly,
And
I got your point, basically. And this is what I call wisdom. If you like among the set of definitions that I have written, so this is way I have defined wisdom in one way, that similar to how intelligence can generate all set of logics, in similar way, wisdom is something that can generate all set of ethics. It's like the generator function. So yeah, that is what I'm working on. And okay, so in that way, also abstraction plays a crucial role. Okay, so that thing I will think about it properly and come back. For now, this recursion thing that I was talking about initially, that if the initial goal is complex enough, then the amount of interpretability steps that we'll have to take will become again numerous. It will not just be one. For simple goals, it will
yeah,
be one.
will not just be one. I agree with that. Like,
So
I think it's correct. I think it does bottom out, and there's a bit of a question of how
strong is that?
practical is it? Like, can we actually do it
Yeah, yeah.
if it's more than like 2 levels or whatever?
Uh, well, it will also depend upon the stakes of the initial problem. It is, if it is something of very high stakes, if it can, like, again, I guess, discover cure of cancer, something like that is the promise, then we can go for full level of interpretation. So it depends upon the stake of that. Like, again, then geopolitics will come in. So it is stupid to argue there. So, but yeah, now it's not a technical problem. It's an optimization problem of humans and their needs. So okay, but there will be like need of multiple bridges. One bridge will not do the job. Okay,
Yeah, I agree with that.
and interpretability basically help us to solve Goodharting by building the bridges that would stop That would make us understand the proxy. Okay. Okay.
Yeah, basically.
So for making general wisdom, okay, now I'll think more and add to this point later on.